Today we are going to practice midpoint formula, both forwards and backwards, and the distance formula and Pythagorean theorem. So our first two examples, we're finding the coordinates of the midpoint of each segment. First one, segment TU, endpoints of T at 6, -12, and U at 3, -8. So remember, midpoint formula takes an x1 plus x2, you're adding the two x's and dividing by 2, and then y1 plus y2 divided by 2. So you're adding your two y's and dividing by 2. So we've got 6 plus 3 over 2, and -12 plus a -8 over 2. 6 plus 3 is 9. So we've got 9 over 2. That doesn't reduce any further, so that is my x value, 9/2. 12 plus -8 is a -20. Then we're dividing by 2, and that does reduce further to -10. So we have 9/2, -10, our coordinate for midpoint for number 1. Number 2, we have segment XY with endpoints of x at -2a and 3a, and y at 0, -1a. So these a's are still part of our process, and they will be part of our answer. They don't just go away because you wish them away. We're going to plug them in. So -2a is x1 and 0 is x2. So we've got -2a plus 0 over 2. So -2a plus 0 is -2a divided by 2 is a -1a. Okay. So that was a -2 divided by 2. It gets us -1a, or just -a. And then our y value, we've got 3a plus 1a divided by 2. So 3a plus 1a is 4a divided by 2. 4a divided by 2 is 2a. Next up, we are finding the endpoint. We're given a endpoint and a midpoint. We want to find the other endpoint. So we have y is the midpoint of segment xz. X has coordinates of 2, 4. And y has coordinates of -1, 1. Find the coordinates of z. So I'm going to use algebra on this one. So we start with our midpoint coordinate. This is our midpoint. And this is our endpoint. I do recommend labeling. So we start with our midpoint. So we've got -1 equaling our x value, our endpoint, which is 2 plus x over 2. Multiply both sides by 2. So that gets us -2 equaling 2 plus x. Subtracting 2 from both sides. And we've got -4 equaling x. So that's our x value for z. And then we need to say anything for our y value. So our y value for our midpoint is 1 equals our y value for our endpoint, which is 4, plus y over 2. Again, multiplying by 2 on both sides. So we've got 2 equaling 4 plus y. And then we're subtracting 4 from both sides. And that gets us -2 equaling 4. So our coordinate is -4, -2. Next up, we have M is the coordinate of segment AB. A has coordinates of -2, -3. M has coordinates of -1, 2. Find the coordinates of B. So we know that -1, 2 is our midpoint. And negative 2, 3 is our endpoint because it's A, it's part of our segment name, and it told us was our midpoint. And we're going to draw our X and Y axes on our graph. Remember that it's not always centered on the graph. This one is because both of these are close to origin. So we've got A at negative 2, 3, so that's left 2 and down 3. And that is A, and that's an endpoint. Yes, label, let you know which direction you're going. Then we've got negative 1, negative 2, so we're going left 1 and down 2. That is M, and that's our midpoint. So that means we are going from our endpoint to our midpoint every time, from end to the midpoint. Doesn't matter which direction you're going. So this one, we're going up 1 and right 1, so positive 1. So we're going to do that same thing, up 1, right 1. Where we land is our point, and that point is at 0, negative 1. So our other endpoint is 0, negative 1. Our next two, we are using the distance formula. And remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you need to label your x's and y's, please do so. Remember that there's an x and y in each ordered pair. It's x followed by y, just like it is in the alphabet. And then we just plug in. So you've got the square root of x2, which is negative 2, minus x1, which is negative 7, squared, plus y2, which is 0, minus negative 4, squared. And you can type it just like that into your calculator. And we're rounding to the nearest tenth. So we get 6.40312. Rounding to the nearest tenth means first place after the decimal. So that gives us 6.4. Because there was a 0 afterwards, that means that that 4 stays. But we're going to do the same thing for our next one. So using the distance formula. So we've got our x and y's. So y2 is 2 minus y1, which is 5 squared plus x. What I want to do, sorry. x2, which is negative 2, minus x1, which is 9, plus y2, which is 2, minus y1, which is 5 squared. And again, you can just type that in the calculator. And again, we're rounding to the nearest 10, which again is the first place after the decimal. And we get 11.4018. Again, we have a 0 after our 10th place, so that means our 10th place stays put. Our next one, we want to find the length of QR and length of ST. So anytime that we don't have the segment bar over top, that is telling us that we are finding the length of that segment. So we can use Pythagorean theorem because it's on a graph. It's easier to make. So we're going up 2, so that's positive 2, and over 7, it's positive 7. So 2 squared plus 7 squared equals length of our cube squared. So 2 squared is 4, and 7 squared is 49. Added together, that's 53. And then we need to take the square root of that because we need the opposite of squaring. And the square root of 53 is 7.2801. Now, if we're rounding to the nearest tenth, like it says, we have 7.28. So we have an 8 afterward. That means we need to round up. So we have 7.3 equaling length of our cube. Now we need to find the length of ST. We've got positive 7 and positive 2. So we have 7 squared plus 2 squared equaling length of ST squared. 7 squared is 49. 2 squared is 4. And added together is 53. And then when you take the square root of that, and that gets us 7.3 again when we round. So that tells us that the length of QR is congruent to our length of ST. Those two segments are congruent. Our next one, the Panther football team has been too disruptive in their classes. And yes, that includes Tommy Lee. So as a punishment, they will have to run either 15 times around the football field or 40 diagonals. The coaches let the athletes decide because if they were paying attention, they would know which was the better deal. Daisy May watches all practices and knows the scoop on this punishment. She's not too happy with Tommy Joe because of his behavior and tells him, you better pick the best option or it may be over, which should be you choose to keep her. So first off, we've got two punishments. We have them running around the football field 15 times, or we have them running the diagonal 40 times. So let's figure out how long it would take to run around the field 15 times. So remember that around the field, we've got to find the perimeter. So 120 plus 120 is 55 plus 55. That gets us 350. And then we need to multiply that by 15 because they're running 15 times around the field. So that's the punishment they choose. So 350 times 15. And that gets us 5,250. Okay, so that's the first punishment. That's around the field. And then we need to figure out the length of the diagonal. So we know two side lengths of a rectangle diagonal, so we can use Pythagorean theorem. So 120 squared plus 55 squared equals C squared. And 120 squared plus 55 squared is 17,425. And then we'll take the square root of that. And it gets us 132.004. We don't want to round just yet, so change our answer. And then we are doing 40 diagonals. So we need to multiply that 132.004 times 40. And that equals 5,280. 80.15 for the diagonals. So now we need to compare our two options. So we've got our around the field being 5,250 and our diagonals being 5,280. So better option would be around the field. So Tommy Joe should choose going around the field. Number 9, which is a pair of vertical angles. So remember that vertical angles are made by two intersecting lines and they are across from each other. So let's look and see what we have. So we've got angle RVT, and angle SVR. So these are supplementary. They are also linear pair. They are not vertical angles. Then our next one, we have angle SVU and angle RVT. So these two angles, those appear to be vertical angles to me, but let's keep double checking. And then we've got our next one, angle VTU. VTU, oh, that's not an angle. So it's not an option. Then we're looking at angle UVS and angle UVT. Again, it's another linear pair. And there are adjacent angles as well. So that means their answer is E, SVU and angle RVT. Okay, number 10. Point K is the midpoint of segment JL. And the length of KL is equal to 3x minus 4, and JK is equal to 2x plus 1. Figure. So we have K is the midpoint of segment JL. So that means that J and L are the endpoints. And because it's telling me that K is the midpoint, that means K is right in the middle. And we know that KL is 3x minus 4, and JK is 2x plus 1. So we have congruent segments here. So that means we can set these equal to each other. So 3x minus 4 equals 2x plus 1. Subtract 2x from both sides and add 4 to both sides. It gets us x equaling 5. And then we can substitute. So KL was 3x minus 4. So 3 times 5 minus 4. 3 times 5 is 15, minus 4 is 11. So the length of KL is 11. And that means that JL is also 11 because K is the midpoint and each side is the same. And our last one for today, angle DEF. Angle DEF shown to the right, which point is the vertex. So I can even know this answer, but just looking at the name of the angle, because the vertex always has to be the one in the middle. So that means that E is our vertex. Then we are asked which rays form the sides of angle DEF. Now this one is helpful if we look at the picture, but I don't have to. Picture tells me that we have to start at E and we're going to F. So we've got one ray is ray EF. Remember to put the symbol over top or write out ray EF. And our other ray, again, have to start at E and we're going out to D. So we've got ray ED. Again, remember, you can put your symbol or write the word in front. Also remember that these letters have to be capitalized because they are points. Okay, go ahead and you can work on your assignment for the rest of the period. Good day.